पूजिते ज्ञानदाते नमोस्तुते प्रेमದಿಂದಲೇ ಸಲಹು ಮಾತೆ ನೀಡು ಸನ್ಮತಿ ಸೌಖ್ಯದಾತೆ ಪ್ರೇಮದಿಂದಲೇ ಸಲಹು ಮಾತೆ ನೀಡು ಸನ್ಮತಿ ಸೌಖ್ಯದಾತೆ ತಾಯಿ ಶಾರದೆ ಲೋಕ ಪೂಜಿತೆ ಜ್ಞಾನದಾತೆ ನಮೋಸ್ತುತೆ ಅಂಧಕಾರವ ಓಡಿಸು ಜ್ಞಾನ ಜ್ಯೋತಿಯ ಬೆಳಗಿಸು ಅಂಧಕಾರವ ಓಡಿಸು ಜ್ಞಾನ ಜ್ಯೋತಿಯ ಬೆಳಗಿಸು ಹೃದಯ ಮಂದಿರದಲ್ಲಿ ನೆಲೆಸು ಚಿಂತೆಯಾಳಿಸು ಹೃದಯ ಮಂದಿರದಲ್ಲಿ ನೆಲೆಸು ಚಿಂತೆಯಾಳಿಸು ಶಾಂತಿಯ ಉಳಿಸು ತಾಯಿ ಶಾರದೆ ಲೋಕ ಪೂಜಿತೆ ಜ್ಞಾನದಾತೆ ನಮೋಸ್ತುತೆ ಜ್ಞಾನದಾತೆ ನಮೋಸ್ತುತೆ ಜ್ಞಾನದಾತೆ ನಮೋಸ್ತುತೆ.
Thank you, Priya, for your melodious invocation song. Now I request Head of our department, Dr. Jain Kulkarni sir, to welcome the audience.
ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. Good morning, one and all. A warm welcome to all dignitaries, speakers, faculty members, staff, and participants for making this faculty development program feasible under the current crisis caused due to the COVID-19 pandemic. Warm welcome to Professor Akki sir, Senior Professor IIIT Dharwad. Welcome you, sir. I also extend warm welcome to Mr. Giridhar Kulkarni, Superintendent Engineer, HESCOM, Belagavi, and President of today's function, Dr. K.G. Vishwanath sir, Principal and Director. Welcome you, sir. I extend warm welcome to delegates, fellow faculty members, and print and media personnel. It is all delight to have every one of you with us in this online platform, as it is an honor itself to welcome you all on behalf of Department of Electrical and Electronics Engineering, Jain College of Engineering, Belagavi. Before launch, let me first acknowledge Dr. Chandra Chairman JJI Group, Bangalore, Shri Radhesham Heda, COO North Karnataka GGI, Belagavi, as our chief partners for this FD. I also acknowledge Professor R.G. Dharwad sir, Senior Director, JJI Group, Professor Uday Chandra sir, Director, JJI Group, and our beloved Principal, Director, Dr. K.G. Vishwanath, for their support and direction. One of the goals of this academic researchers to stimulate the policy debates and anticipate issues likely to emerge as a result of first, policy mistakes or omissions, and second, changing economic and societal contexts. The FTP on trends and challenges in the next generation energy technologies intended to present a scope of trends in modern energy technology, highlighting the practical problems and possible solutions for the same. The FTP further aims to offer a great opportunity to bringing together professors, researchers, and industries around the globe on virtual platform to share the ideas and highlight on the recent technology. Last but the least, this online FDP not only proves the virtual platform is the future, but also urges us to share our wisdom to make this world a better place. Being the program convener, I would like to thank Dr. Devraj Sarkar and Professor Vinod Patil for their hard work in arranging this particular FDP program. I would also like to thank all the rest of the faculty members of the Department of Electrical and Electronics Engineering for their effort behind this FDP. Thank you, one and all, and once again, warm welcome. Before concluding my welcome speech, just I tell about our institution for the information of the speakers and the delegates. Just I'll share the few PPTs, only 4 slides. I have got Jain College of Engineering, Belagavi. At Jain College of Engineering, Belagavi, we ensure that our students rise beyond the average and set remarkable standards through novel thinking and creative ability, which are imbibed in them during their learning years at our institution. The institution started in the year 2010, catering civil engineering, computer science and engineering, electrical and aircraft engineering, electronics and communication engineering, and mechanical engineering undergraduate programs. Also, the PG programs offered by the institute include MTech in construction management in civil engineering department and MTech in power system engineering in the department of electrical electronics engineering. Apart from that, we have got MBA program as well as the MCA program. Further, the college has a research center in all the departments. GGI Group is an education provider and an entrepreneurship incubator in India. The group successfully operates 85 plus educational institutions with 51,000 plus students and more than 7,000 employees engaged at the from K-12 to undergraduate and postgraduate levels, spread across 64 campuses all over the India. A leader in the education sector and pioneer in the venture sector. About the Department of Electrical and Electronics Engineering, our vision is to create technocrats with the moral values in the field of electrical sciences. With a mission, we facilitate students develop ability to comprehensive understanding of state-of-art knowledge in electrical engineering concept. Take up research and development activities in the field of electrical engineering science. Apply their technical skills for betterment of a society. The department accomplishes a power system simulation lab, which is established in the year 2014 under the flagship of Vision Group of Science and Technology VGST, Government of Karnataka, and Electrical and Electronics Engineering Department, Jain College of Engineering, Belagavi. The department has received 20 lakhs rupees grant from the VGST and also supported by the JGI of around 10 lakhs rupees. For developing this particular lab, it is a hardware come the software lab. It is hardware modules are interfacing with the computers. Then you can take the research work as well as the training program on these particular modules. The Department of Electrical Engineering is signed the MOU with HESCOM on 27/2019 for mutual transfer of the technology from the student side to the HESCOM, and from HESCOM their practical experience it is gained by our students. And also we have got a consultancy cell in our department with we are tried with the first year basic electrical lab kits according to VTU syllabus, were designed, developed, and industriously it is designed by our staff of electrical and electronics engineering department. The department offering the electrical and electronics engineering undergraduate program with a 60 intake, and also we are offering the power system engineering MTech program with the intake of 24. The department is also recognized as a research center. Around 8 students they are pursuing their PhD program. In this particular, we have conducted more than 25 plus workshops since from 2014 onwards. In this particular academic year, we have conducted around 6 workshops, including this workshop FDP on the challenges faced in the next generation technology. The department laboratories, we have got a control system lab and power electronics lab, machines 1 and 2 labs. Apart from that, we have got a power system simulation lab and high voltage lab, and also we have got a digital and the analog electronics labs. With this brief introduction of a department and a college, once again I welcome all the delegates as well as the dignitaries for this 3 days FDP program. Over to the Nagaraj sir.
Thank you, sir, for the welcome speech. Light is a symbol of seeking blessings from God. I request the dignitaries to light the lamp.
Let's light the lamp. Thank you.
Thank you, everyone. Now I request Dr. Devraj Sarkar to present the overview of the session.
Good morning, everyone. Welcome to the Faculty Development Program, titled as Trends and Challenges in Next Generation Energy Technologies, hosted by the Department of Electrical and Electronics Engineering, IIIT chapter. The FDP is divided into distributed in 3 days of the 3 different sessions. The first day we are having Shri Giridhar Kulkarni, the Superintendent Engineer, HESCOM, Belagavi, and he'll be talking about the topic challenges in next generation energy technologies. On the second day, we are having the session by Dr. Pratyasa Bhui of IIT Dharwad. His topic is impact of renewable energy integration on power system stability. And then on the third day, we are having two speakers. The first speaker is Dr. Jain. He'll be talking about the basics of solar forecasting. And and the next session we are having our respective HOD Dr. G.H. Kulkarni will be talking about next generation electrical technologies and electrical policies. So this is the brief description of the sessions we are having. Hopefully you'll have a nice time about this FDP. Thank you.
Thank you, sir, for the overview of the session. May I request Professor Shidlingaya to give an introduction to the keynote speaker?
Good morning, one and all. Thanks for giving me the opportunity to introduce today's chief speaker, sir. It gives me an immense pleasure to introduce today's keynote speaker, Dr. Channappa Akki, Head of Electronics and Communication Engineering Department and Professor of Computer Science and Engineering Department at Indian Institute of Information Technology, Dharwad. Sir has completed PhD in Electronics and Computer Engineering and Master of Technology Computer Science in 1990 from IIT Roorkee and Bachelor of Engineering in Electrical and Electronics from University of Vishwesvaraya College of Engineering, Bangalore in 1982. He has experience in electrical and computer science courses for more than 12 years inside and outside India. He used to be the senior specialist in Tata Elx Limited, Bangalore, and senior consultant in Wipro Technologies, Bangalore, and he was an assistant professor, faculty of IT in Philadelphia University, Jordan. He has a faculty experience associated with a number of engineering colleges and universities like SJBIT Bangalore, SIT Tumakuru, Basaveshwara Engineering College, Bagalkot, Karnataka University, Dharwad, Dayanand Sagar University, Bangalore, and etc. We had trained a senior IT professional towards building their domain expertise for 7 years. He has been involved in supervising the research work carried out by the faculty members of engineering colleges affiliated to universities in Karnataka and has a field of research and his field of research involves networking in general and wireless technologies, big data analytics, and security in particular. He has immense academic and administrative experiences. He was a registrar acting in IIIT Allahabad, professor and chairman of the Department of CT in Dayanand Sagar University, Bangalore, head of 3 departments, namely Computer Science and Engineering, Information Science and Engineering, Master of Computer Applications at SIT, Tumakuru, Karnataka. He is also a member of Board of Studies for Computer Science and Engineering at state level Government University in Karnataka and also KIIT, Bhubaneswar and Reva University, Bangalore. He is also working as a secretary of Board of Governors, IIIT, like preparing agenda, ETRs, interacting with the board members, etc. In addition to this, he has also published the many papers and also reviewed for the reputed journals and conferences. So, with this brief introduction, I welcome Dr. Channappa B. Akki sir to this event. Welcome you, sir. Thank you.
Thank you, sir. Thank you, sir, for the introduction to the keynote speaker. Now it's time for the most awaited moment. I request Dr. Channappa Akki, sir, Professor, IIIT Dharwad, to present the keynote address. Please, sir.
Sir, kindly unmute yourself, sir. Sir,
Sir,
you
your
are
sound
not
is not
audible, sir.
audible.
Hello.
Yes, sir.
Am I
Now it is
audible?
audible, sir.
Yes, yes. Good morning. Good morning to all the participants. There are about 24 participants, right? So my topic given is next generation energy technologies. It's a too vast field. Energy technologies, that to next generation. Okay, let me put my sincere effort. We shall see how far I can justify this allotment. Okay. Starting with before energy, power. Power is the ability or capacity to do something or act in a particular way. For example, power of speech, right? Vak Shakti, what we can call it as in Kannada. Organizer, how many are from Karnataka? Can I know?
Sir, nearly 90% are from Karnataka, sir.
Okay, thank you. So next, energy is the capacity for doing work. What are the different forms of these energies? Potential, maybe potential or kinetic, or say thermal energy, electrical energy, chemical energy. There are, for example, nuclear energy. There are various forms of these energies. Electricity is also one type of energy. So how, for example, energy, you might have heard of energy drink to build our body, energy giving food to keep us healthy. So all these energy factors. So what is there in energy technology? What constitutes the energy technology? Because our lifestyle is sustained by energy. Without energy, we are no more. When we are no more, there is no lifestyle. So energy needs a deeper inspection. Where all we can find energy and what are the technologies existing, what all the technologies coming up in next generation, how we can research in that domain is the main theme of my talk. Okay. So energy, to look into a deeper way, three things can be observed. One, what is optimization? What is innovation? What is creation? Optimization, that is how we can use and deliver efficiently this energy, how we can use it, what all the applications related to energy, and how we can deliver this energy from one point to other point or to the task expected efficiently. Why this efficiency should be looked into as we go ahead in the talk, we shall come to know about it, because efficiency plays very important role. So usage and delivery are the two things where optimization can be looked into, can be considered. Second one is innovation. That means our existing energy sources, are they sufficient for our daily lifestyle, or it is not enough? If it is not enough, why it is not enough? And what we can expect, what we can make use of the natural resources available on this earth as energy. We need to look into all those future energies which we can think of and innovate. What is there in innovation? First of all, what are the new generation energy sources and how it should be? Like, energy should be clean, it should be reliable, it should be affordable, it should be sustainable. For example, petrol, if we look into it, we cannot continue with this petrol for a longer time because it is getting exhausted. So how do we run our life without petrol? So is there anything in the nature which can replace this petrol? That is innovation, where exactly the research community has to look into. And next one is creation. What are the technologies existing based on energy? Is there any new technology which we can investigate that works on only new kind of energy? For example, vehicle can, as of now, run on only petrol or diesel or gas. When these three resources are not available, how we can run our vehicle? So that comes under energy technology. Energy technology will also include regulations, policies, like your college during the first speech, they told what all the regulations we have in the institute, what all the policies we are coming up, and all those things. Likewise, for next generation energy technologies to sustain, we should have proper regulations and policies. So these are to be part of our creation, third point. So optimization, innovation, and creation, these things. Further, all these energy technologies can be looked into four major parts. One is energy generation, other one is energy conversion, third one is how to store this energy, and finally, what is the impact of this energy if we utilize on the environment. What are the point? Four things. How we can generate new energy, how we can convert this new energy for the suitable form where we can apply it to some application. Third one, is it possible to store energy? What are the ways to store this energy? And is there any impact on the environment of this new energy? So all these factors should be looked into. To come to one particular generation, energy source generation, there are two things. One, stationary source of energy and dynamic source of energy. So first, if I look into stationary source energy generation, one project, you can Google for this, Akki Energy. Sometimes they call it as, this is used for small batteries. They call it as AHI battery, aqueous hybrid ion battery. Okay. This battery is very cheap, long-lasting, large-scale aqueous electrolyte sodium ion battery that uses salt water. So salt water is it is available in large quantity. We can use that to store electricity. In developing the battery, right, researchers across the globe have come out with a simple set of goals for economically competitive energy storage devices, including necessary price point, environmental impact, cycle life, and efficiency. The result is a battery optimized for stationary storage applications such as microgrid support, off-grid generator optimization, and grid-level energy services. This is one, what should I say, is new energy-based equipment. Second one to quote is microfluidic microbial fuel cell that converts bacteria into power. Look at the innovation. Bacteria can also be used for the generation of power, and this power can be used for some task. Okay? So the task of this, what these kind of cells can be used. These are also small, low-cost fuel cells, and it converts, as I said, bacteria into power. The device, the size of this device is less than a hair. That is about 300 times smaller than a raindrop. So this can be used for some kind of application where mainly for pharmaceutical companies it can be used for. And next one is high frequency diodes having extremely high cutoff frequencies in the range of hundreds of terahertz. Very high frequency diodes. And one more I can quote here is solar power is an innovative technology to power small mobiles through the use of a person's everyday movement. Right? When we walk, right, electricity can be generated. That electricity can be used to charge our mobile. Next one. So in all technologies, when technologies are invented, there is a term called value of death. Value of death. What is that value of death? It is the combination of all challenges to implement this technology. Risk management, what are the risks, what is the market study analysis, or what is the implementation, like experts shortage or developers shortage or resource shortage. All these are challenges to implement particular technology at the beginning. So collectively all these are called as generally value of death. For energy technology, what is the value of death? There are two values of death. The first one is the challenge of obtaining venture capitalist to go from laboratory research to development of a product prototype and proof of that product's basic marketability. So risk involved in productionizing it is the first, because someone has to invest money on that. We don't know whether the product will succeed in the market or no. But however, we need money to implement and test that marketability. So this is first challenge. This we call it as value of death, first value for energy technology. And later, when once a product is shown to be marketable, when it is successfully being sold in the market, it must also cross the second level, that is commercialization value of death. By finding sufficient private equity, debt financing for demonstration projects, first of a kind commercial scale projects, and manufacturing facilities. Okay? So these are two values of deaths in case of energy technology. Energy, so energy technologies are the primary determinants of energy availability, fuel choice, of nature of byproduct emissions. Okay? So the primary determinants of energy availability, like fuel choice, end use efficiency, all this stuff. So energy R&D is the vehicle by which new technologies become available. R&D is, you can Google for US universities or Indian universities anywhere who are working on these energy technologies. Like one I can quote is Carnegie Mellon University has come out on, even they have what I should say, started many startups which can generate products related to energy technologies. Having gone through little bit of energy technology, but what is this energy technology innovation? It can be defined as processes. It's very simple. It's what is energy technology innovation? It is the process that improves existing technologies. Very simple. Whatever technologies are available right now, if the processes, if we can come out with a process which can improve the existing technology, it becomes energy technology innovation. If there is any improvement that shows, right, efficiency is good for the same input, or input is reduced, keeping the same output. So energy saving is there. It can also be said that to create new ones and assist in technology transfer from the laboratory to commercial widespread use. That is energy technology innovation. So there are a few other things to look at. Some of them is energy and the environment. We see many things related to energy. The moment we talk about energy, environment also comes into picture. Hence, new generation energy technology should be environment friendly. New energy generation technologies should be environment friendly. That means adverse impact on the environment should be reduced. Or the parameters which are impacting the environment can be minimized, can be removed altogether. Such a technology can be called as energy technology.
Hello.
Yes. Hello. Am I audible? I think I'm audible because it is unmuted.
Yes, sir. Yes, sir. Yes, sir. Yes, sir. Yes, sir. It is audible.
Thank you, Giridhar. Can you see me? Okay.
Yes, sir. Yes, sir. Yes, sir.
Okay. So energy and environment, as I said, the impact on the environment should be minimized, or the things which are impacting the environment must be used, must be removed. Such a technology should be invented. For example, waste to energy technology, WTE they call it as, waste to energy technologies can convert the energy content of different types of waste into various forms of energy which can be used for something. So wastage can be made useful to generate energy. That energy can be used for something like gobar gas or solid waste or liquid waste or semi-liquid waste, whatever is there, we can make use of those wastes to generate or to convert the energy which can be used for something else. These technologies, next generation technologies, can be called as WTE technologies. That is, they convert energy content of different types of waste into various forms of valuable energy. And environmental aspects of food waste to energy conversion, this is also there. So whatever food we waste, can we generate Yes.
Mahesh sir, kindly mute yourself, sir.
Hello.
Sir, kindly mute yourself, sir.
Okay, thank you, Mahesh. That is food waste to energy conversion. Next one is the environmental characteristics. So environmental characteristics should be maintained properly. Harmony should be there in the environment. It should not spoil our environment. Such technology, if you can come out with, you can work on that, and that becomes next generation technology. Many universities work on that. Along with the same thing, green energy technologies with distributed energy resources like DERs. What are DERs? To give one example, turbines or solar panels. They have recently huge attention in smart grid due to their harmonious relationships with nature. You can refer to Rana and Lee, published in 2015, or Yan et al., published in 2013, on this distributed energy resources. Okay? Or there is another paper which talks about combined utilization of wind turbines and solar panels. Okay? That can also be looked into. By using this kind of hybrid energies, what may happen is that the reliability of tools and power system operations can be increased. If, for example, solar system, during daytime, solar panels can be used to trigger something, and during night time, wind turbines can be used to trigger the same application. Yes. So these are called hybrid energy technologies. People are finding out this also. One more better example is there. I will show you. It is on wireless communication. We shall talk about that also subsequently. And to generate new energy technologies, before going for it, risk analysis has to be applied to energy systems. Deaths from energy. Talk about this. There is a very good paper on risk analysis applied to energy systems by Herbert Inhaber. Okay. He talks about risk concepts, and you can just Google risk analysis applied to energy systems. You will get this paper also. Why it is required? See, the various technologies, may it be thermal energy, may it be electrical energy, may it be any wastage to energy technologies, all these things are using certain kind of energies. When we are using them, perhaps affect the health of the people around that or animals around that. So these two risks, they have classified into two things. Immediate. Immediate means if it may affect immediately and the person might die immediately. That is called early. Or it may late, that nuclear power station may impact his health, and gradually over a period of 1 year or so, he start looking or seeing those symptoms. So this is late. So,
Sir, sorry to interrupt you, sir.
okay.
Sir, Giridhar Kulkarni, sir, Superintendent Engineer, HESCOM, Belagavi, has joined us.
Okay.
We welcome you, sir, on behalf of our college and department. So next session is going to commence at around 10:30 a.m. Yes, sir.
Okay.
Please continue, sir.
10:30.
Please continue, sir.
Okay.
Yes, sir.
Okay.
Yes.
So, different energy technologies can be characterized as early or late depending on the impact. The division applies primarily to nuclear power. For other energy technologies such as coal, gas-fired, or electricity, deaths occur almost immediately after an accident or air pollution incident. For example, construction and mining accidents, which are shown elsewhere in on this earth to be a substantial part of some energy technology risks, produce deaths either immediately or within few days. The effects of air pollution from fossil fuels are often calculated by the increase in deaths after a pollution alert. When a dam fails, deaths are immediate. Okay, so next generation energy technologies can be characterized as early or late depending on the casualties it produces. And there is a this philanthropy and energy. Renewable energy technologies have enjoyed dramatic price reductions over the past almost 20 years. Wind power has dropped from 25 units per kilowatt hour to less than 3 rupees per kilowatt hour today. The central region of the United States is known as the Saudi Arabia of wind energy. The 11 obvious states from the Dakotas to Texas have the wind energy potential to supply more than the total current electricity consumption of the entire US. Look at this. So this is philanthropy and energy. So few thought-provoking issues or challenges which I quote here. Those who are, you're all, yes, learned people across the globe, you can look into this. Each one can become a research problem. Can we use the flowing water in a small canal to generate and store electric power which can be used later? Right? Small canal is there which are moving towards our agriculture lands. In that canal, can we put some device which can generate and store electrical power which can be used later? I think this is existing right now. And use small boats to know the water pressure, depth, oxygen content, animals using 3G or edge technologies. That means those small boats would have a smart SIM card, and that will be connected to any base station, nearby base station. It will be collecting all those informations. Data can be assimilated, collected somewhere in the server. Later on, some machine learning approach can be used to study that data. Sorry. And robots to replace human, drones to replace manual AHM. AHM stands for Aircraft Health Management or Maintenance. So nowadays drones, when they land in any airport for health checkup, instead of doing it manually, why not we send drones and capture that area? So drones would require small energy, and then they can capture the photos at various points of the aircraft, and they can send it back to the server where people can check, is there any crack in that? Okay, so something like this. applications are many. And also drones can be sent where human being cannot go. That what we call it as post-disaster management. For that also we can use drones. In robots, for example, Jain College of Engineering may be spread across few buildings. So when let us come to the office, why the person should go and distribute to all the departments? Why not a robot can do this? Robots work on smaller efficiency, so energy efficient technology.
Sorry to interrupt you, sir.
Yes, 5 minutes.
Okay, sir. Sorry, it's a humble request from our side, sir. So please conclude, sir. Time is running out. Please, sir.
Okay.
It's a humble request, sir. Humble request from our side.
Time is over.
1 minute.
Okay, sir.
So ocean and small hydro energy systems or simulation tools or modern power electronic technologies or energy planning can be two topics for research. So 3 slides I left because of shortage of time. Thank you. I like to thank Vinod Patil and others from JCE, Jain College of Engineering for associating me in this academic event. Thank you. Thank you all the participants.
Thank you, sir, for conveying profound knowledge to every one of us. I request our Principal and Director, Dr. K.G. Vishwanath, sir, to present the presidential remarks.
A very good morning to all. Dr. Channappa Akki, Professor, IIIT Dharwad, Dr. G.H. Kulkarni, Dr. Dharwad, and Shri Giridhar Kulkarni, Superintendent Engineer, HESCOM, Belagavi. Sir, it gives me an immense pleasure to be a part of this 3-day faculty development program. As you all know, because of COVID, we are conducting this faculty development program online. And of course, it's our experience that with this kind of new technologies, I'll say everybody is everywhere. I mean, we can have interactions irrespective of the physical presence of the learned personalities. So we thought, let us use the technology platform to disseminate the knowledge amongst all. So with that idea, this workshop is scheduled, and we are very fortunate to have very learned speakers for these 3 days. And we've got participants also who are participating all over India. So we have got a platform where knowledge can be shared using the technology. And this is communication technology what we are using. Exactly the same way, the topic of this 3-day workshop is about the challenges in next day energy technology and even impact of renewable energy, integration and power system stability. Of course, basics of solar forecasting, and finally next generation energy technologies and electric policies. So we should be able to know more and more about these topics, and I hope the knowledge gained by all the participants could drip through to all the students who will be learning with the staff. So the deliberations that will happen these 3 days will surely throw more and more light on this emerging technologies, and we should be able to utilize this challenging time in a much better way. I hope everything will go well, and all the very best for the 3 days faculty development program. Thank you very much.
Thank you, sir, for the presidential remarks. Every good beginning leads to a good ending. I request Professor Vinod S. Patil to present the concluding remarks.
Good morning, one and all. I would like to begin with a quote: "An ignited mind is the most powerful weapon on the earth, and this is got to be through education." I deem it a great honor and privilege to propose vote of thanks on this memorable occasion. On behalf of the Department of E&E, JC Belagavi, I express my deep gratitude to Dr. Chaniraj Roychand, the founder and chairman of JGI Group. I sincerely thank management of JCE, principal and director Dr. KG Vishwanath sir, for facilitating us to organize this 3 days faculty development program. I am thankful to today's Chief Professor Channappa Akki sir and Shri Giridhar sir for readily accepting our invitation and gracing the inaugural function virtually and their insightful address. I thank all the plenary speakers. I acknowledge the unwavering support received from all the HODs. I would like to thank our beloved HOD sir, Dr. J.H. Kulkarni sir, for his constant encouragement and support throughout the event by ensuring that we do right things in right way. I would like to take this opportunity to place on records my hearty thanks to all the coordinators and committee members for the perfect support and guidance they have extended to this faculty development program. I thank teaching and non-teaching staff for their support and involvement in successfully organizing this event. I would also like to thank all the student volunteers for their untiring support. Finally, I am thankful to all the delegates who have turned up in such a great number, not only from our state, but also from other states and departments for their enthusiastic participation and kind cooperation in the event and making this event a great success. Lastly, but not the least, I thank one and all present here. Thank you one and all.
Today's first session is about to commence immediately. I request the audience to be online. I request Professor Lakshmi Brungi to introduce our today's invited speaker, Shri Giridhar Kulkarni sir, to our audience.
Good morning, one and all. It's my immense pleasure to give a brief introduction of today's speaker, Shri Giridhar Kulkarni, Superintendent Engineer O&M Circle, HESCOM, Belagavi. Sir is a gold medalist in electrical engineer, and he completed postgraduate diploma in business management from Institute of Chartered Financial Analysts of India. Sir has joined his service in 1988 as a junior engineer in electrical at KEB Kolar Goldfields. He served as a AE at 110 kV station at Humnabad, Bidar district. Then he served as a AE at O&M section at Bhalki. Then he served as AWE of O&M substation at Chincholi, Kalburgi district. Then he was promoted as executive engineer and was promoted, as posted to O&M division at Humnabad. Sir currently promoted as Superintendent Engineer of O&M Circle, HESCOM, Belagavi. We are lucky to have you, sir. Thank you.
Thank you, madam, for presenting an introduction to the speaker. Now I request Giridhar Kulkarni sir, Superintendent Engineer, HESCOM, Belagavi, to present their talk on challenges in next generation energy technologies. Please, sir.
Good morning, everybody. I am Giridhar Kulkarni, Superintendent Engineer of Hubli Electricity Supply Company, Belagavi. I am looking after the distribution of energy across Belagavi district. Am I audible? Please tell me.
Yes, sir, you are audible, sir.
Yes. Okay. Thank you. So I'm very happy and honored that Jain College of Engineering College has invited me on this talk. And on this occasion, I am just sharing my experiences. Since 1988, I am working in distribution. For a short period, I worked in transmission line that is KPTCL, our parent organization, it is Karnataka Power Transmission Corporation. This organization takes up the work of transmitting energy from generating point to the load centers. In that organization, I worked for some 3-4 years, and afterwards, I am working in distribution of energy in Gulbarga Electricity Supply Company. I worked, and now I am working in Hubli Electricity Supply Company. At present, I am sharing just the experience, as I said, I gathered during all this my service. And I think there are many challenges in the field, which as an engineer, there needs to be some inventions, some hard work, etc., etc. Now, the main challenge before us is India being a developing nation. We need to give power to everybody, be it industry, be it agriculture, or whatever. The power should be our motto is providing quality power at affordable prices for overall growth of economy, for overall growth of India. Now the issue here is, if we are speaking about just this part of the state, Belagavi, we are having some 7 rivers flowing across district, and lot of irrigation activities are going on. Huge population is there, population density is huge. So power requirement has gone up many folds. Power, without power, just people cannot imagine the life without power. Now, as I was saying, providing quality power at affordable price, both are the challenges. Now, providing power itself was a main idea of state. Even Government of India, Rural Electrification Corporation, used to electrify all the villages. So electrification of the villages, of the habitations, etc. happened. South part of India is very much forward, and it is electrified long ago. But as you can see, Deen Dayal Upadhyay Gram Jyoti Yojana, etc. state and central government has brought up, and in this program, lakhs of villages which were not having power was given to the villages during the last financial year, 2-3 years back. If we take the example of our Belagavi district only, there were some places in Khanapur Taluka where power was not available. Since independence, since history, they were not having power. So we provided power to them by way of drawing the transmission lines, 11 distribution, primary distribution lines, and at some places we provided generators and solar panels also to give power to those people, because it is not possible to draw the line through the forests to the places. So that one portion of the job, that is providing connectivity, accessibility of energy and connectivity of energy to all the population across India, was a challenge before Government of India. And we are fortunate enough that we provided power connectivity to everyone across India by way of implementation of DDU-GJY recently, and by way of taking up infra providing works during last regimes through Rural Electrification Corporation. Now the next question comes of, though we have given power, is it a quality power? Are there interruptions? Whether the voltage conditions are okay? These are the issues and major challenges before us. Now to provide power, one thing is, I am going back to the issue. Though we provided the connectivity, we provided the lines, we provided transformers, secondary lines, and electrical connections to the poor households also we provided under Deen Dayal Upadhyay Gram Jyoti Yojana and RAC and Rajiv Gandhi Gramin Vidyutikran Yojana and all. But next issue was, though the connectivity was given, whether the power is available. The issue of providing the power was, all the villages were having only 6 hours power supply, and recently they were having only 6 hours of power supply, or as the load condition go on and as the power supply position is there, this used to happen. Now this 6 hours power supply was just insufficient for the people of the rural area. If there are some small businesses, some small industries, then that became an issue, and for that we bifurcated. First, Gujarat was the first state to bifurcate the feeders, 11 kV feeders, into 2 groups. One feeder runs for exclusively IP sets, only IP sets. only IP sets will be connected on this feeder, and the other feeder, it runs across all the villages, which all other installations other than IP set are connected, right from household connections, commercial connections, and then industrial connections, then power, water supply, street light, etc., except IPC. So by way of this, by having two lines to each and every village, we ensure that we give power to IPset, regulated power to IPset, and we are giving 24 hours power supply to rural areas also other than IPset. So Gujarat was the first state to do it, and afterwards Karnataka took up the project, and we did it. And now under DDU-JJY, this DDU-JJY project across India, feeder bifurcation work is taken up, and the feeders are bifurcated. And for IP loads we are giving regulated power supply, and for other than IP loads we are giving 24 hours power supply. So this is the network arrangement we did in case of secondary, primary distribution and secondary distribution, that is 11 kV and LT and distribution transformers, etc. Now we are coming to availability of power and then reliability of the system. Now, as far as availability of power is concerned, I can say at a brief that power generation in India as on date is satisfactory because of solar power, wind power, and many private players, though since private players are allowed to generate energy like sugar factories, cement industries, etc., they generate power. Whatever power they are having, they generate, they use it. Whatever is left over, they can pump back to the system. We electricity companies, we will be purchasing that energy. Likewise, recently all of you might have come across an issue that solar rooftop power. Each and every household can install solar rooftop over their houses, and they can utilize the energy generated, and there is a net metering concept. So there is a energy meter, that is net metering. The concept is like this: whatever energy is generated by solar panels is utilized by the consumer, by the owner of the house, and whatever is left over after his utilization will be pumped back to our system, and whatever energy has been pumped gets pumped to our system. We will be paying 9 rupees 20 paisa per unit of the energy whatever they are pumping out. And whenever the energy they are generating falls short of their requirement, they can draw the energy from the network. That way also many people started installing solar rooftop, and then solar. Karnataka is leading in solar. Even in Madhugiri district, this Tumkur district, Madhugiri Taluka, there is 2,000 megawatt solar power plant has come up. So power availability, we can say we are somewhat satisfactory. We are in somewhat satisfactory position as on the day. Why I am saying as on the day is because power consumption will be going up again and again. Now, though the power generation is sufficient, power is generated, but it needs to be transmitted to the load centers. And for that, we need to have strong transmission line network. You might have come across the central government's announcement, one nation, one grid. We were not having single grid across India. We were having many grids. We are having many load dispatch centers. See, load dispatch center means if Karnataka, we are having state load dispatch center, which is a center wherein all generating stations information is available, load flow is available. So this load dispatch center monitors the flow of energy, monitors the loads. If the load is rising to unmanageable situation, then they ask for disconnecting or shedding the loads. We will be taking power from central grid, from central government, also central grid, central government. So wherever we draw power from central grid, then we need to follow some grid codes. We are not allowed to draw the energy at lower frequency, that is 49.9 hertz, not below 49.9 hertz. If we are drawing below 49.9 hertz, then we will be penalized for drawing that energy, and we will be automatically disconnected. By that, this is ensured by way of having under frequency relay and receiving substations. If the frequency falls below the range, then the feeder gets automatically disconnected. So all these things are monitored by State Load Dispatch Center situated in Bangalore. Then again for the southern states, Andhra Pradesh, Karnataka, Tamil Nadu, Kerala, and Telangana, one regional load dispatch center is there that is also situated in Bangalore. So this regional load dispatch center, this takes care of the whole region. They monitor SLDCs working, they monitor flow of power, they monitor frequency, they monitor voltages, etc. Likewise, there are regional load centers in Mumbai and Delhi and Calcutta, etc. Regional load centers are there. Though the monitoring used to happen at regional levels, but we were having transmission lines. We were kind of having, for example, from Belgavi to Kolhapur, there is a line linking two states. 220 kV line is there. So these two states have made some arrangement and got that connected. And whenever there is surplus power or shortage of power, power transmission takes place. But a single grid across India was not there. So one nation, one grid policy was framed by Government of India, and under that policy, 765 kV line construction is happening. Now I come from Gulbarga. So from Solapur to Raichur and from Raichur to Bangalore, Nelamangala, this line is constructed. 765 kV line is constructed. This line is constructed by PGCL, Power Grid Corporation of India Limited, and then it will be maintained by PGCL only. So this 765 voltage kV will be again reduced to 400 kV and so on. So by this way, central government has constructed transmission line by which we can really transmit power from one state to another state. For example, if we are having sufficient power surplus in Chhattisgarh, we are just not in a position to take power to Karnataka, because though the power is available here, though the requirement is here, we cannot draw the power because of non-availability of the transmission line. That we call, in our language, it is commercial language, it is corridor, power corridor. We can just compare it with trucks and goods. Of course, we are purchasing goods from, say, Bangalore or Mumbai. We want to get it here, need is here. But we need to have some transportation facilities, as trucks, etc., to transport that food grain from Mumbai to Belagavi. That's the issue. So here, in case of energy, for transmitting energy from Chhattisgarh to Karnataka state, etc., we need to have transmission line, and those transmission lines were not available. And now Government of India is constructing. And see, I am speaking about the challenges. Though the power is available there, though the requirement is there, that power there is wasted unless utilized. And here we are stripped of power. So we need to have some strong and reliable transmission lines for transmitting power from one point to another point. This is one line that is constructed. And one more thing is, high voltage DC transmission also takes place, that is happening from Orissa to Kolar in Karnataka. High voltage DC, 1000 kV line it is. So that power transmission also takes place, and here at the Kolar, we convert the power from DC to AC, and then we are using it at Karnataka. So to have, though power generation is happening, and establishment of generating stations, whether those should be established near the source. For example, hydro, we cannot shift it here and there. That will be there wherever the potential is there. Hydro generating stations will be there. Whereas when thermal power station question comes, it can be established anywhere. Either it can be established near collieries, or it can be established near load centers. Now, whether to establish them near load centers or near collieries is a question, is a decision, business decision or a feasibility decision. Exactly it is. If by or some other means, nowadays it is understood that it is better to have generating stations near collieries, because transmission of power from one point to another point is cheaper than transmission of coal from one point to collieries to load centers. Because the rail network and construction of rail and transmission of coal, etc., is a challenge. That's why constructing transmission line is the only option to take power from one point to another point, surplus point to load centers. Now this is a challenge. We need to construct the lines, and land acquisition issues are there. Farmers are not allowing for erection of towers. Now tower-based technological challenges, I am coming to the point by going round and round, that The tower size which we are constructing today is acquiring some 1/4 of the quarter, some 10 guntas or 8 guntas or 4 guntas when we construct this 765 kV transmission line. Now there is technology involved. For example, in case of 110 kV towers, we developed narrow based towers also. For example, if I want to draw a 110 kV line in Belagavi city from outskirts to center of the place, then I just cannot draw even 11 kV line because there is a ROW problem. This is the challenge. Then I have to go for construction of narrow based towers. This is a technological challenge which remains a challenge till day, and it is the place where young engineers can concentrate on. They can develop something good for this. We can reduce the cost also by that way. It is costly affair to construct the line and get the power from that place to here. And when the construction cost goes up, naturally the cost of energy at which we will be distributing the energy to the consumer goes up. So this cost we need to reduce, then only we can give the power at affordable rate to the end consumer. That is the challenge before us, and that is the issue that needs to be taken up. That's why HVDC etc. is being planned nowadays, and that's what is happening. Now that is one thing, transmitting energy from one point to another point. And second point, when we come to 220 kV stations, 400 kV stations, earlier while we were developing initially in case of power generation, the issue there was to just have a connectivity and to give a power supply. Then now comes the reliability question. Reliability of any line should be 99.999%. That is the expected level. But reliability of the line is not to that extent. Even if I come out of the subject and speak about communication, even communication reliability is also not 99.999%. Nowadays we are seeing call drops, this, that, etc. Likewise, electricity reliability. As a professional, I am sitting here, and if some program, VIP program is going on, or some important program is going on, to what extent I am confident that power will not go off? Is it 100%? I am assured that just yes. Can I say yes, I can give power supply to without interruption? No, I just can't say. I am saying, what I am saying is, please have some DC set, have some batteries, and then have the power, because I just cannot promise you that you have reliable power supply. That is the situation. That is the ground reality. It is not the person to be blamed. It is the situation to be blamed, or situation for which we have to take care of this network. Now the second point I am coming to, the challenges here is, though we are having power, though we are transmitting the power, but whether the power that is available coming over here, can we give reliable power to the people? For giving reliable power, if we go and study European system of power arrangement, England, America, or for that matter Singapore. I attended one seminar in Hyderabad. Singapore people came over there and they were just showing how they take care of the equipments, lines, etc., and how they reduce the interruption. And it is just unbelievable to think that and to hear that the power interruption in Singapore during 1 year was only for 24 seconds, if I remember correctly. 24 seconds. That is the power interruption. There is no interruption. What does that mean? Does that mean that there are no line faults? Does that mean that there is no rain, no wind, no falling of pole, no damaging of cable, nothing? No, it is there. But they have alternate source for everything. For 220 kV station line, they have alternate source. 1 220 kV station, they will be having sources, 400 kV lines, at least two 400 kV incoming lines from two different sources, two different generating stations. So if one generating station or one 400 kV line goes off for any reason, then definitely another line will be there, and these two lines will be parallelly connected and synchronized. We will not be knowing that some line has tripped. As a consumer will not be knowing, but as an engineer sitting there, he will be knowing by way of tripping of breaker, etc. Faulty portion will be isolated, and the other one which is healthy will be supplying the power. Now I have a time, I need to have some people to attend to that, and within shortest possible period we will be attending to that fault, and we will need that line for healthy. So imagine if that this alternate source of 220 kV line, 400 kV line is not there. If it is not there, then what happens? This 110 kV to 400 kV line, if it goes out of order, it takes 2 to 3 days to restore the power supply, to identify the fault. If there is conductor snapping, then we are going we are still in a traditional way of stringing the conductor, this, that. There also, just I am coming over there also, we need to improve our technologies for attending the faults, for stringing the conductors, for re-erection of towers, etc. A lot of work is to be there. We are just in olden days. If we go to European countries, etc., they just attend the line faults by utilizing helicopters. They place the jumps hotline, that online they do all preventive maintenances, they do online. So that is what where they have gone, and we are still not there. We need to do a lot of work to give that facility, to make that facility available, to give reliable power supply to consumer. Now, I was speaking about the alternate power sources for each 220 kV station, two 400 kV lines. Likewise, for each 110 kV station, which is the next step down voltage station, 220 to 110, that happened in 220 kV, 110 to either 33 or 11 kV. The line comes from 220 kV station, 110 kV lines come from 220 kV station to 110 kV stations. Now this 110 kV station also, if it is radially fed means only single source is there. Then again it becomes a problem, as we just discussed about the interruption of 400 kV line. If that is again interrupting, 220 is interrupting, then 110 kV station will have problem. 220 by 110 kV station will have problem. Then 110 kV line, if it is a single line, then it will have problem. So here again we need to have one more alternate source, at least one source. There must be two sources from two different 220 kV stations, and those should be synchronized and kept parallel. That is phase sequences, voltage, etc. Synchronization, as all of you will be knowing. Synchronized lines should be available. If the one of the line gets faulty, or one of the 220 kV station gets faulty, or one of the 400 kV line gets faulty, this 110 kV station should not suffer, and the other line should be in a incapacity of taking up the load. Here I would like to focus one thing, that redundant capacity, we need to have redundant capacity here also. There is possibility that both the lines will be feeding the same station. If some 110 kV stations peak load is, let us say, total 100 megawatt or something, both the lines will be feeding this 100 megawatt. Now, if one station goes off, one line goes off, only 50 megawatt can be taken, not 100 megawatt. So each line should be capable of taking 100 megawatt. That is, double circuit must be there, or multi circuits must be there. So if one goes out of order, the other available network should be capable of taking the 100% load without interruption to anyone. That is the need, and that is, though we are making availability of all these things nowadays, we are KPTCL, our parent organization, is constructing many 110 kV lines and many 33 kV, many 220 kV lines only for interconnecting 110 kV stations and 220 kV stations to have alternate source of power, so as to give reliable power to the people. Now the cost reduction, now the designs, etc. are again the issues. This tower, that conductor, these are the challenges. These are the cost involved things. Nowadays land value is going up. Nowadays cost of the material is going up. Design aspects can be changed. Tower design can be changed. We can utilize to my optimum level all the material, and we can reduce the cost so that we can give the power at affordable level. That remains a challenge before us. Now we need to have, as we discussed, we need to have two sources for each 110 kV station. Again, for each distribution transformer, we need to have two sources. For example, if we are taking example of Bengaluru city, or for example Belagavi city or Hubli city, we are having UG cable, underground 11 kV cable connectivity, and each transformer we will be having, we are having ring main units, RMUs. That way I can take load of any feeder on other feeder in case of any faults. It takes some time, but not automatically. As I was saying, till to 110 kV station, that both the lines will be parallelized, they will be parallel, and if one trips, another will be taking up the load without even noticing of the interruption. So that doesn't happen in 11 kV distribution system, but within shortest possible period we will be arranging power supply. So this happens since I heard in England, London, etc. There two lines will be coming and they will be terminated on one distribution transformer, and it is automatic distribution automative system. DAS is there, distribution automation system. By that way, If one line gets faulty, then automatically the group operating switch of that faulty line will get disconnected and the other line will get connected to the distribution transformer. That way, within no time, within seconds, or within the time somebody notices it, power supply will be, even the interruption cannot be noticed by the people and power supply will be arranged. That distribution automation system is again a challenge for us. I will come next to the place. Now these ring main units we have proposed, we have kept in place in Belagavi. So I understand the interruption level in Belagavi. Just an example, I am taking interruption level in Belagavi city. Before going for underground cables was a lot because of many trees, etc., many issues. Now that is reduced to the barest minimum. Though there is interruption, but it is to the barest minimum we could do, and that is because UG cable and ring main units were having in Belagavi. Now let us move to the rural area, where we can see that Indian population, so out of total Indian population, 70% of the population, by the some rough calculation, 70% of our population depends on agriculture sector. Now, if I take the example of Belagavi district, some 70 to 80% of the load, total load, is of agriculture only. As at the beginning itself, I told 7 rivers are flowing, lot of irrigation potential is there, and each and everyone wants to get his land irrigated to have to come up to survey. So that way, lot of demand is there, and there we are supplying 11 kV line and NT line. It is just not possible to give alternate sources of power to the farmers and correct voltages to the farmers. Now the rise in demand of power by farmers is going up again and again, and it is exponential. It is not somewhat which can be forecasted based on the past growth. If past growth says something, the future growth will be something more and more. That is just really becoming unpredictable how it goes up, and there are many factors for this. One of the factors is when I joined for the services, there used to be 3 HP pump sets for farmers because water level was very comfortable and they could lift the water. Now this lifting of water, they need 7.5 HP to 12.5 HP pump sets. Now that is because of that, to irrigate same area of the land, they need more power for drawing the water. Now here there is a technological challenge I see based on my experiences. So these motors, whatever nowadays 5-star motors, 3-star motors, and all that is manufactured, and we are making it mandatory for them to utilize. But it is becoming difficult because those motors will be working in the comfortable voltage level, voltage variation of plus or minus 3%, 4%. For example, if I am promising and if my system is designed for voltage of 433 volts at secondary level face to face, then it will be working from 420 volts to 440 volts. Some difference this way only. That way, only sufficient voltage, if that is available, then only it will work efficiently. Otherwise, it will trip and it will not work. Otherwise, it cannot give up the efficiency to what extent we are expecting that to deliver. Now, what happens because system and the demand growth is not allowing us to maintain that voltage. Unexpected rise in demand, etc., is going up, and hence the voltage levels at the end consumer, they are not satisfactory across the area. We can just correlate with scenario across the India also. So there are many places where improvement has really happened, but still there remains, and this is a dynamic situation. If today the voltage condition is okay, tomorrow it is not so. We need to go on planning continuously to strengthen the distribution system. We have to pump a lot of money in this sector. Distribution, providing 11 kV link lines, providing distribution transformers, LT lines, etc. Then providing alternate lines, study forecasting, then this taking care of the load rise, and then giving a correct power to the people, it remains a challenge. Of course, there are many technological challenges right now. I do have heard the two advanced stage of studies you are doing. That's fine. I am just sharing my experience. Here, the real challenge lies in giving power to the end consumer. Whether he is satisfied, whether he can survive, that is the issue. This is the farmer's issue. They needs to have a sufficient power, water. Then there is water. They need to have. They just want sufficient quantity and quality of power. That is the challenge here, and we are struggling day in and day out. There are many Raita Sangha organizations, they have come up with ideas. We are struggling. So here there is a challenge. Here some technical advancement is necessary. Some voltage distribution transformer design aspects are to be studied, and there are many failure of transformers. This remains a real challenge in the field, where one energy sector has to do a lot of things. This is about electricity, agriculture sector. Now I come back to the industrial sector. Here there are many process industries across around Bangalore or around this Belagavi, etc. So if there is interruption, if there is low voltage, if there is voltage fluctuation, their work really gets hurt. Their pipelines will get jammed. Their output will be affected. They will be suffering a lot. Now that's why whenever we have a this talk with industrialists, we generally sit together at Chamber of Commerce and Industries and discuss their issues, and we'll try to solve some problems. We have some industrial areas here, there, everywhere across India. Now these industrial units, they need continuous power supply. Just they cannot afford of interruptions, and I cannot ask each and everyone to have your own arrangement of setting up DC set and then diesel, etc. It is against my business principle. I cannot ask him to make alternate arrangement. Of course, when it becomes unbearable, we say that you have some independent arrangement, your own arrangement, but that is not the case. That is neither a solution. So for that, to give uninterrupted power supply, we laid some UG cables also there, and we improved the infrastructure by way of addition of transformers, power transformers, drawing additional lines, etc. So when we want to reduce the interruptions, we have to go for UG cable, underground cable, and the cost of the cable is very high, and it is rising day by day. And India is not, I understand, is not a major manufacturer of UG cable. In fact, South Korea, etc., those countries are having a lot of expertise in manufacturing of these cable. India is having capacity, they are manufacturing, but the R&D that is necessary, cost reduction issues are there. Just while beginning itself, I said power should be made available at affordable rate. We are manufacturing the cables, and if the cable cost is going up day by day, then just we cannot give the power at the affordable rate to the consumers, and hence the challenge remains here of designing a cable which becomes cheaper. That is a challenge before us, to reduce the cost of laying of lines, and by way of reduction of the cost, we can go in for more conversion of the overhead 11 kV lines to underground 11 kV lines, and thereafterwards we can give uninterrupted power supply, quality power supply at affordable rates if the cost of the construction and laying of the cable comes within the limit. If it goes up, then the cost of the energy goes up. Right now, the cost of the energy has gone up. Recently, you might have seen many people were complaining during these 2 months of lockdown during Corona. 2 months bill we gave, and the differences were huge. That was because of the consumption they did. They consumed the energy, that much energy they consumed, and the energy cost after some slabs, after 200 units, it goes to 7 rupees, etc. So it really becomes costly and unbearable for a common man to do it. So that is the challenge here. Broadly, I am saying is to make available the energy, quality energy at affordable cost, and affordable cost availability of energy can be made only by cost reduction, and that cost reduction can only happen if there is some R&D work in construction, manufacturing of these cables, towers, etc., etc. These are the issues. And then comes a new concept you might have heard. I'm focusing upon it. It is a demand side management. Now the approach for giving this reliable power at affordable cost also includes, apart from having sufficient generation capacity, apart from having good network, reliable network, and apart from having redundant capacities to take care of the untoward incidents, exigencies, line faults, etc. And apart from these things, we need to concentrate on manage demand side management. What exactly is demand side management? Roughly, I will tell you. We are going for LED bulbs. light emitting diodes bulbs, etc. Because the earlier bulb which was there consumes more energy, gives less illumination. So illumination efficiency should be highest. For that, we have to go for these such types of bulbs which can give more illumination by consuming least power. That is a demand side management. So what all I need is illumination and not power consumption. I will be happy if I am getting less bill and if I am getting sufficient light. That is the very easy thing to understand what the demand side management is. Means my demand I should manage, and government on its larger scale has to take up the issue of this demand side management continuously. Now this demand side management industrialists are taking up. Now flattening of the peak load curve issue is also being addressed by industrialists. We are having the facility of time of the day facility in meter, wherein we encourage utilization of power during off hours of peak hours, and we penalize the power consumption during peak hours. So that is the facility we are giving. We are encouraging the industrialists to use the power in off peak peak hours, so that our load curve will become flat. Otherwise, the load curve is not flat; it is steep during some time, and that during that time only. For example, the power consumption, power demand in Delhi city or Bangalore city during some peak hours, that is during evening, say 7 and 8, etc. If it is going up like 500 megawatts, 600 megawatt, and afterwards if it is to 200 megawatts only, then see. For all practical purposes, I need to construct all stations and lines for taking 500 megawatt load only. That extra expenditure, that extra infrastructure I need to put for taking care of this peak load. Whereas the average load will be only 200 megawatts. So to take care of this, KERC, Karnataka Electricity Regulatory Commission, has come up with the idea of providing TOD all across India. This idea is there. So we are discouraging utilization of energy during peak hours, at least for industrial utilizers. So they are taking care of that. They are saving a lot of money in that also. So such needs, such things, and such innovative ideas are to be brought up to flatten the load curve, so that the amount that we are pumping in creating the infrastructure will remain barest minimum. Otherwise what happens if this goes up like this? If for example, there is a vertical growth in all the cities, Mumbai, Delhi, etc. Vertical growth is there. Now we have laid some lines. That line will take some load. If the vertical growth continues, if the per capita consumption of the citizen goes up, then I have to provide more infrastructure to cope up with the demand of the people. And then there is ROW problem. There is limitation for creating the infrastructure. That becomes an issue. For that also, there are many things like during peak, to take care of peak loads, batteries are kept stored in substations there, and in particular load centers only, that energy, rather than importing energy or rather than transmitting energy from another source to this source by way of providing more infrastructure or upgrading infrastructure, batteries are being kept there and peak demand is being managed. So this is an innovative idea where these batteries are kept. This arrangement is done to take care of the peak load, to flatten the curve. To flatten the curve, once we become successful in flattening the load curve, then only the cost required for construction of infrastructure will be the least one, and that will be the optimum utilization of the infrastructure will happen. That will only give us required results and returns, and it will help us to reduce the cost of energy we will be delivering to the people. That is there some issues, such issues are there. So for young engineers, this is also a challenge, that peak loads, flattening of the peak loads is an issue. And for such innovative ideas, as I was telling, TOD, and then I was telling about providing batteries, etc., in big cities at sub center to take care of the peak loads. That issue is being taken up, and such further issues need to be taken up in future also. Now afterwards, if we come to the consumption of rural power, that is IP sets, etc. Here, though it is not an electrical engineering subject, but it is of importance, national importance. Flood irrigation, whatever is happening, is a major concern right now. It is first of all wastage of water, that's a precious commodity. Then it is a wastage of energy. Then it is a soil conservation. Then that all these things needs to be taken care of at national level, at all levels, and we have to educate the people, and we need to find some solution for this, like going for drip irrigation, sprinkler irrigation, and all. Because of that only the power requirement will come down. They will be storing the water once, and afterwards they will be using the water at gravity, and thereby the demand will come down. Otherwise, the electricity demand is going up, and this is because of flood irrigation. And they will be pumping water, they will be drawing water, the whole crop will be standing in the water. Soil erosion will happen. Soil will be of no use after some period, and this is a national waste. Water wastage is there, electricity wastage is there. On this front also, it is a major challenge before us, that we need to, it is for the betterment of the electricity sector, that one need to concentrate on the irrigation activities and their requirements. Their requirement is to grow more, to be okay. So for that, they will be, farmers will be trying. I had to come from the farmers family background. So there, the need is that way only, and that needs to be fulfilled. And for that, to take care of the rising demands, we have to go for some farmers education, for some engineering works in agriculture engineering, or making this drip irrigation and sprinkler irrigation facilities at the cheapest. Government is taking all actions by giving subsidies for purchasing all these things, but still some lot of work needs to happen there, and that is necessary for that. And afterwards, the next challenge remains here is manpower. Now, it is not sufficient that land is fertile, but it is necessary that the minds are fertile. If the minds are fertile, anywhere people can develop anything. There are many examples of this issue. So people, correct education to the people, correct expertise, and quality manpower is a need of the hour. Though the manpower is available, we can see by many studies, etc. Employability of the people, to what extent the employability is, that remains the question. In government sector also, that is the issue. So employability, after employment, what happens, what is the commitment to the work, how the problems are to be solved, whether we are taking it as a criticism, whether we are taking it as an attack on us if there is no voltage, no power, or we are taking it as a feedback. We should be compassionate enough with the people. We have to work with all honesty and with some knowledge. So knowledgeable people's participation in this sector particularly is very, very important. So these are the issues on which I like to speak about. Anyway, I am not speaking too technical, neither I am speaking about the present trends, etc. But I thought of speaking about the real challenges we have faced, we are facing in the field, by way of giving power to the end consumer. Because any invention, any work, whatever is being done at larger scale or whatever, if it fulfills the need of a end user, if it fulfills the need of the common man, then only it has some meaning. So we are at a cutting edge. We are trying to people, and these remain the challenges. And here, I think I made my point here, and I am very much thankful to Mr. Kulkarni from Jain College of Engineering who has given me an opportunity to speak out before all of you. Thank you very much.
Thank you, sir, for your valuable talk. Sir's talk has thrown light on every aspect of next generation energy technologies. Our head of the department, Dr. H. Kulkarni, sir, will share a few words.
Thank you, sir. Thank you for your invitation. You are accepted readily, and you are given experienced in your talk regarding actual challenges in the field, then how to tackle it. Okay, thank you very much, sir, on behalf of the Department of Electrical and Electronics Engineering.
Thank you, sir. Thank you.
Sir, one question from participants' side, sir. Sir, why can't, this is a question from SD Hirekode sir, that why can't we install fault passage indicator for maintenance of power supply line, sir?
See, we are having fault locating machines, fault passages, relays, etc. That is restricted to 220 kV lines, 110 kV lines, and 400 kV lines. We have some relays, zones, etc. will be identifying in what zone, what type of fault has happened, and fault locating machines also we are having. But in case of 11 kV line and L lines, it is not possible. We are not using that rather, and that is being restricted to that thing. And one more thing is, see, we will have faults. We need to, you are right, we need to have some good technology to identify the faults and to rectify fault. My point was to have alternate source of energy by the time, till the time we restore the power of the interrupted line. For that only, constructing line, etc. is a problem, and tower construction, etc. is a problem. This remains a technological challenge to design some towers and etc. and get the power here transmitted at the point. We are using that, those relays, etc. we are using fault locating, fault passage relays already we are using.
Hello.
Yes, please. Hello. Is that clear?
Hirekode sir. Sir, any questions, sir?
No, sir. My point is clear, sir. No problem. Right. Thank you, sir. Thank you.
Okay.
I request any other participants, if anybody is having questions, kindly pose your questions, sir. I think no questions, sir. We'll conclude the session.
Now I request Professor Vinodes Patil to deliver the concluding remarks.
It's my privilege to propose the concluding remarks on this session. I wish to express my gratitude to our Principal and Director, Dr. K.G. Vishwanath sir, for supporting us and providing a platform to conduct the FTP. I, on behalf of Department of E&E, GC Belagavi, I express my sincere thanks to our speaker of the session, Shri Giridhar Kulkarni sir. Thank you for your insightful address on the challenges and whereabouts of the power distribution of our district. Sir, your explanation on the topic was exemplar. I am very grateful to Dr. J.H. Kulkarni sir for giving us an opportunity to organize this event. No program can become successful with a single person. So, big thanks to the team of EE department for their support and all our volunteers. Thank you for making this event successful. Your contribution. I thank all the delegates who joined Thank you very much.
By this, we have come to an end of the first day session of the Faculty Development Program. Tomorrow, we'll be starting the session by 10:30 a.m. The link for the tomorrow session will be shared on the WhatsApp group. Thank you. Thank you, one and all.
Thank you, sir.